So good evening and welcome back, and let's keep going. It's as you can see, the time is a bit like approaching to the second exam, but I'll try to finish it before hopefully Saturday, and so you'll be able to see all the materials. So it says, what are the so we are still on we're still on exam 2 from 2016 fall semester, and we're on question number 4 right now. It says, what are the molecular geometry and the polarity of the OCS molecule? So for this kind of problem, we still need to like do the Lewis structure first, and let's draw the Lewis structure of this OCS molecule. And the way to draw Lewis structure is to, as you can see, to calculate out the the total number of valence electron first, which is 6 plus 4 plus 6 equals to 16 electrons, and then we put the atom with the least electronegativity in the middle, which is a carbon in this case. And we just put down the two other molecules aside and try to connect them together in order to make it one molecule, and that causes us 4 electrons, and it's 12 electrons left. And let's just put down electrons around the carbon, no, around the atoms with the more electronegative characteristic. So that's 12 electron in total, and that's 12 electron in total, as you can see. So we pretty much used all the electrons. So the next step is to calculate the formal charge on each atom, which for oxygen is 6 minus 7 equals -1. Actually, I should be able to skip right now, so I'll just do like so this is -1, this is +2, and this is -1. Apparently, there's a way to do it better, which is I believe this way. It would be not very nice if you still do not have the ability to draw a very good Lewis structure at this moment. So please try to get help if you cannot, do Lewis structure in a very efficient manner. So as you can see, there's a 2 major electron group around. What is this? There's a dot here. Delete. Delete. Okay, cool. And there's another major electron group. And so there's 2 groups around the central atom, which leads to a linear. And there's no lone pair electrons on the central atom either. So there's only 2 groups around the central atom, which leads to a linear. And due to the fact that actually this atom and this atom, the sulfur atom and the oxygen atom, does not have the same electronegativity, so there should be like a net dipole moment pointing this way, because like it's a linear, like there's a dipole moment over here, and there's a dipole moment over here, but this one is like stronger. So this one does not necessarily, so the dipole moment on the sulfur does not necessarily counter the dipole moment pointing towards the oxygen, and that's why it's a polar molecule. So the answer should be linear. Oh no, my screen is really like slippery these days. I guess it's because like it's wet and it's polar. So the correct answer is C, I believe. And we'll end here. Why there's a pen around here again? I'll try to switch it out.